All right, so here is for the first section. As a heads up, this is section 6.1 in your textbook, and this is going to be broken up over 3 days because this is a pretty long section. So here is for the first part of this section. So some basic vocab that you need to know moving forward. First, the actual word trigonometry, because like I said, this is an introduction to trigonometry. That's our unit. So the word trigonometry means measurement of triangles. So what we're going to be working with throughout this entire unit is triangles and kind of seeing how angles work within them as well. So a little review from geometry from last year. An angle is two rays that have a common endpoint. So remember we could have an angle could look like this. We could have an angle like that. We could have an angle like that. Or we could have an angle like this. So we have acute angles, which is anywhere from 0 to 90 degrees. Right angles is exactly 90 degrees. Obtuse angles, anywhere from 90 to 180, and then straight angles is 180. So we have our two rays in an angle. So what we're going to be working with now is we're going to be working with angles specifically in the coordinate plane. So when we have our coordinate plane, remember we have our XY axis. So the terminal side of an angle is the ray that rotates around the coordinate plane. So let's say I have an angle here. So let's say I have this angle here. So I have these two rays. This is going to be my terminal side because it's the one that's rotating all around. And then I have my initial side of an angle. This is the ray that does not rotate. So what we're working with these angles of rotation, the terminal side is going to be rotating all around the coordinate plane, but then the initial side is going to be staying completely in place. Then another little vocab again, the vertex of an angle, that's the shared endpoint of the two rays. So there's the vertex, there's a vertex, there's a vertex, and then in this, there would be the vertex. And then in our angle in the coordinate plane, here is the vertex. So this one is very, very important, an angle in standard position. So standard position is where the initial side lies on the positive x-axis, which remember, positive x-axis is all of this. The vertex is at the origin, and the terminal side rotates throughout the plane. So we are mainly going to be working with angles that are in standard position. And then one other little tidbit, angles are most commonly measured in degrees. So that's what we're going to be working with in this section. In the next section, we're going to be working with a different unit of measurement called the radian. So when we're talking about rotating these angles around, we have positive and negative angles of rotation. So if I'm talking about a positive angle of rotation, that means that I am going to be rotating, my terminal side is going to be rotating counterclockwise around the coordinate plane, and it starts above the x-axis. So that is in this visual right on the left. So remember, there are 360 degrees in a circle. So what we're looking at in this coordinate plane is if we're rotating something, we are looking at 360 degrees. So in quadrant 1, we have degrees anywhere from 0 degrees to 90 degrees. If any angles have those measures, then the terminal side is going to be in quadrant 1. 90 to 180, the terminal side is in quadrant 2, 180 to 270, so on and so forth. And then we have negative angles of rotation. So negative angles of rotation rotate clockwise. So instead of starting above the x-axis, that goes below. And then they rotate clockwise. So let's go ahead and let's do some examples. So I want to know which quadrant will the terminal side lie in of the following angle measures. So again, so we're going to say that this is in standard position. So if I have 120 degrees, here is my initial side. 120 degree angle is going to be somewhere around about here. It's going to be somewhere around there. So remember, my initial side is always going to be my positive x-axis, so that's not moving. So 120 degrees, that's going to be in quadrant 2, the terminal side. If I'm looking at 260, referencing what's on the last slide, it's going to end up in quadrant 3 because 260 degrees is between 180 and 270. So what that looks like is it's about that. So this is my angle, and then what the angle looks like is it's rotating all around like that. Now I got negative 30 degrees. So since I have a negative, I have to start below my x-axis. So I go about like that, and that is my negative 30 degree angle. So my terminal side is in quadrant 4. So the difference again between positive and negative, positive you go up and around counterclockwise. Negative, you go down and around clockwise. And then I have negative 180. So if I have this, negative 180 gets me here. So the terminal side actually is not in any of the quadrants. Where it is actually on the negative x-axis. Because again, so when we have these angles of rotation, we go around 360 degrees, negative 180 is going to get us halfway of one of the revolutions. So that's just going to get us on the negative x-axis. Okay, so again, now I want to determine the angle of rotation that we have here. So first thing, so I'm looking at this. When I'm trying to figure out the angle of rotation, first thing I want to figure out, is it positive or is it negative? So we're looking at the red markings on each of these angles. So it starts above the x-axis here, so I know that I'm working with a positive angle of rotation. And it goes around through the first quadrant, through the second quadrant, through the third quadrant. So that means I know that I have at least 270 degrees. So then if I keep going and I stop here, this 30 degrees tells me that this angle here has to be 60 degrees. And that's because each quadrant has to add up to 90. So here, that first what I drew, that's 270 degrees. Right, so you can read that. So that's 270 degrees. And then I add 60 to that. So this angle of rotation is 330 degrees. For my next one, I'm starting below my x-axis, so that means I'm working with a negative angle of rotation. So looking at this, I see here that I'm going all the way around through the first two quadrants, so I have at least negative 180 degrees. And then the green portion tells me that that angle is 110 degrees, so I have negative 180 degrees, and then that angle is 110, but remember, we're still going in the negative direction, so we're going to be adding negative 110 to that. So I have negative 180 plus negative 110. So that ends up getting me negative 290 degrees. And that's it. That's the angle of rotation. On this next one, again, it's positive. I'm starting above the x-axis. It ends up in quadrant 4, so I know it's between 270 and 360 degrees. The green portion of the angle tells me that it's 75. So I know that all of this, again, is 270 degrees. So all I need to do is 270 plus 75, and then that gets me 345 degrees. And then on this last one, I know that it's negative because I'm starting below my x-axis, and the green tells me it's 160 degrees, which is negative 160 degrees. Next thing is coterminal angles. So coterminal angles are angles that have the same initial and terminal sides. So what this looks like is, let's say I have a 60 degree angle, a positive 60 degree angle. So that's going to look something like this. So I'm going to say that that's 60 degrees. But I can also have, let's say that I rotate an angle all the way around, and then it ends up in the exact same spot. And then let's say that angle is 60 degrees. In terms of what the coordinate plane looks like, those angles are going to be looking the exact same, but there is another revolution with the one on the right. So this is a 420 degree angle of rotation. So we're going to be working with angles that are more than 360 degrees and less than negative 360 degrees. So to find angles that are coterminal to one another in degrees, all you need to do is add or subtract 360 degrees from the angle measure given. So for this first one, I have 120 degrees. So if I add 360 to that, I have 480 degrees. Then if I subtract 360 from that, I get negative 240 degrees. And then if you were to draw out those two angles, then you would see that the terminal side ends up in the exact same spot. Looking at negative 30, if I add 360 to that, that gets me 330 degrees. And then if I subtract 360, that gets me negative 390 degrees. Now for negative 540. If I add 360 to that, that gets me negative 180. So sometimes you will not automatically get exactly where you need in one step, because 540 degrees means that there's more than one revolution around the coordinate plane. So then what you need to do is keep subtracting until you get a positive number. So if I have negative 180, or I'm sorry, keep adding 360 until you get a positive number. So I have negative 180, and then if I want to add 360 to that, that will get me my 180 degrees. So I have negative 540 plus 360 equals negative 180. That does not get me a positive one, so then I need to add 360 again, and that gets me 180. And then negative 540 again, a negative coterminal angle with that, just subtract 360 from that, and that's going to get you negative 900 degrees. Last one, 900. So again, if I add 360, I get 1,260 degrees. Subtracting 360 from 900 gets me positive 540. That's not going to work. So then if I subtract 360 again, that still gets me a positive 180. That one also not going to work. So then if I have to subtract 360 again, and then that gets me negative 180 degrees. So it turns out that these two angles, negative 540 and, or I'm sorry. So that's how that played out. So determine the following angles of rotation and find one coterminal angle. So if I look at these, I'm starting again. This one's going to be positive because I'm starting above my x-axis. So if I follow this revolution, I'm going around 2 full times. So I've gone around the entire coordinate plane twice, which means that I have at least 720 degrees there. And the way that I got that is each revolution is 360 degrees. 2 times 360, 720. And then from the green, I can tell that that is 130. So I have 720 plus 130. So that means that this angle of rotation is 850 degrees. And then a coterminal angle to that, it doesn't specify positive or negative. So what we can do, I'm just going to add 360 because I like working with the positive ones. So I have 850 plus 360, 850 plus 360, and that gets me 1,210 degrees. All right, so then for these next two, we're going to go over these next two in class. And then the last thing for today, we have angle pairs. So we have complementary angles. Complementary angles are a pair of angles whose sum is 90 degrees. So it's two different angles who form a right angle. So we have a right angle here and then two angles in between. So those two angles are complements of each other. Then I have supplementary angles. Supplementary angles are a pair of angles whose sum is 180. So pretend that that is a straight angle. And we got that. So I have those two angles. So the important thing is both complements and supplements, they have to be positive angles. We do not have negative angles as complements or supplements. So sometimes we may not have complements and both complements and supplements of all angle measures. And the way that we know that is if I have an angle measure that's bigger than 90 degrees, then I cannot have a complement because then I would have to subtract it, and it has to be a positive angle. So let's look at these examples. So to find the complement of 67 degrees, what I need to do is I need to subtract 67 from 90. So 90 minus 67 is 23. So that means the complement of the 67 degree angle is 23 degrees because they add up to 90. And then supplement, all you need to do is subtract your angle measure from 180. So 180 minus 67 is 113. So that's my supplement. Looking at this next one, 147 degrees. First of all, like I said, an angle measure in order to have a complement has to be less than 90 degrees. Because it has to be, all complements and supplements have to be a positive angle. Since this angle measure is greater than 90, there's no complement. But we do have a supplement because it is less than 180. So again, subtract it from 180 and that gets us 33 degrees. Okay, and then the last two we will also be doing in class as well.